In this class, we are going to introduce the concept of permutation and combination. We have already seen two basic counting principles, that is addition and multiplication principles. So a permutation of n objects is an ordered arrangement without repetition. We will discuss everything in detail, but ordered means that if I write L1 R1, then it is different from R1 L1, and repetition without repetition means L1 L1 cannot be used multiple times. So an R permutation is an arrangement using R of the n objects. Similarly, combination can be defined as unordered selection. So in both the cases, repetition is not allowed, but permutation is ordered while combination is unordered. So we denote them as PNR and CNR. So to obtain the formula for PNR, let's say I have to arrange two objects out of n objects. So the possibilities are n minus 1. There are n positions for first one and n minus 1 for the second one. So Pn2 is n minus 1, Pn3, Pnn, or similarly I can write Pnr, and if I write it in the form of factorial, then it becomes n factorial divided by n minus r factorial. Now if you recall the first example of addition multiplication principle, where we discussed the French book, German book and all of this, so there the order was not there. So when I write L French book F1 and G1, so order is not considered. It means I have to consider the order, then I have to multiply it by 2. So if I wrote 6 cross 8 for French and German books, and if order is there, it gets multiplied by 2 or 2 factorial. So this is the permutation. So from permutation, if I have to obtain the combination, then I must divide it by 2 factorial, which represents the number of the objects where the order is not required. So it means that if I have to compute CNR, then I must divide PNR by R factorial. And this is how the formula for CNR looks like: n factorial divided by R factorial n minus R factorial. So let's try the first question. How many ways are there to arrange 7 letters in the word systems? So when I write systems, one observation is that since letters are distinct, therefore it is a problem of arrangement. The other observation here is that all letters are not distinct. If all would have been distinct, then it is simply P7, 7. But it is not P7, 7. Now the problem is that among these 7, there are 3 objects, these 3 S, which are similar. It means that there are multiple ways of obtaining it. One way is that I pick all 3 objects out of 7, which are 3S, and use the permutation for the remaining 4. If you want to do it directly, I can simply do it as P7, 7 and divide it by 3 factorial. Why 3 factorial? Because these 3S, their order has no role. If one S is at first position, the other one is third, fourth, then all 3, 4, if I interchange their position, I will get the similar answer. That's why I have to divide the total number of the possibilities by 3 factorial. So that's why either I wrote 7C3 multiplied by P4, 4, it's not P74, because after arranging the 3S, only 4 are remaining. Or you can write directly as P7, 4, which means you arrange the 4 letters Y, T, E and M first, which is P7, 4, and the remaining gets arranged only in one way. Or the third one is you write P7, 7 and divide by 3 factorial. The other part says that how many of these arrangements do 3s appear consecutively. So to appear them consecutively, I consider all 3s as one letters. If I consider as one letter, then the remaining letters are, so in total there are 5 letters. That's why the answer is P 5, 5. The next question is how many arrangements, different 8-digit binary sequences are there with 6 ones and 2 zeros. Now if you assume all ones and zeros, everything is distinct, then it is simply P8, 8, which is 8 factorial divided by 6 factorial, because 6 ones are similar and 2 zeros are similar. The other approach is, since they are similar, so it could be a problem of selection, which means out of 8 you select 6, or out of 8 you select 2. So this is how it can be done. You can read this question and we will do each part one by one. So first one says that the committee consists of 3 women and 2 men. So of course this is a problem of selection, because when you write a committee, then within the committee order has nothing to do. There are women W1, W2, W3, man M1, M2, whichever way you write, it remains the same committee. So order is not there. That's why it is a problem of selection. So when it is a problem of selection, it is 7C3 multiplied by 4C2. Before I move to part B, one quick observation here is that when I write 1100 or 0011, they both are different. It means the order is not there within the identical objects. But if there are two different kind of the objects, order is there, which has already been covered when we use the formula for combination. The second part is committee can be any positive size and equal number of man and woman. So equal number means that there could be 1 woman and 1 man, plus there could be 2 women and 2 men, there could be 3 women and 3 men, or the last possibility is 4 women and 4 men. So first two parts we have already discussed. Let's move to third part, where committee has 4 people and one of them is Mr. Baggin. So one of them is Mr. Baggin. It means we need 3 more people, and there is no condition that they should be man or woman. It means out of 10 we simply need to pick 3 more people. So 10C3. At least 2 women. So at least 2 women means 7C2 and 4C2, 7C3, 4C1 and 7C4, because in total I need only 4 people. Now in this case, the other approach might be we pick first 2 women and then pick any 2 out of the remaining 9. But if you see that in this case there is a lot of repetition and the answer would not match. Why repetition? Let's say you pick W1, W2 first, and out of the remaining 2 you pick W3 and M1. But in the other case, let's say you pick W1, W3 and remaining 2 would be W2 M1. These two committees are same. So this is the most important observation, that when we are computing the total number of the outcomes, we need to avoid the repetition. So last one says that Mr. and Mrs. Begin both cannot be in the committee, and two of each sex. So let's say Mr. Begin is there in the committee. If it is there, then I just need one more man out of 3, but I need 2 women. Now this should not be 7, because I already know that when Mr. Begin is there, then Mrs. Begin is not there, so remaining women are 6. If Mrs. Begin is there, so I need 2 men and 1 woman, and if both are not there, then I need 2 men and 2 women, and then I use the addition principle. The same can be done with subtraction principle, where you compute the total number of the outcomes and subtract the case when Mr. and Mrs. Begin both are the part of the committee. So we will be doing many more questions in the next class. Thank you.